morning. So I just want to remind you of scientific notation. Scientific notation. This should be really just a reminder, because I know you do this in chemistry, you even do it in physics some, so this is just kind of a little like, oh yeah, I remember that. So 4.05 times 10 to the 5th power. Remember, that just means you take 4, and then I usually do 0.5. Here's my decimal, and I need to go over 5. When it's a positive, it's getting bigger. So I'm going to go 1, 2, 3, 4, 5. And then I usually fill those in and put my decimal here. I usually put an equals 1, 2, 3, 1, 2, 3. So this is 405,000. Okay. And then if it were the other direction, if it were to the negative 5 power, that means it's getting smaller. When I write it, I'm going to write 405. I usually write it over here because I know it's negative. It's going to get bigger. The decimal's here, and I need to move 5. So I'm going to go 1, 2, 3, 4, 5, and then put my decimal. I'm going to fill this in with zeros everywhere my bump is. So this is 0. You always put a 0 in the front. 1, 2, 3, 4. 1, 2, 3, 4, and then 405. So just a reminder how it works. Now, in IB Math, you know what? I did not see this anywhere on the exam last year, but they wanted me to show it to you. If I take 4.05, we'll say times 10 to the 2nd power. So this is a number. And then I want to add it to, I'm going to say 2.35 times 10, to the 3rd power. Okay, now there's some rules in here about what we can and can't do when we're adding, when we're multiplying, things like that. But you know what? It doesn't really matter, because all I have to do is 4.05 times 10 to the 2nd power. I'm going to put parentheses around it, plus 2.35 times 10 to the 3rd power. So there, here, looks just like that. I hit enter, and it's 2,755. If I wanted to turn that into scientific, remember the decimal's here, so I want to do 2.755 times 10 to what power? Let me grab a different color. 1, 2, 3. So this would be to the 3rd power. All right. So let me readjust that a little bit there. If you struggle with what I just showed you, come in and see me. I guarantee a 2 or 3 minute tutorial and you will have scientific notation down. Now, something else I want to remind you of is from chemistry, you learned something called sig figs. I don't know if you remember that or not, but significant figures. You do that a lot in chemistry, in physics a little bit. Here's what sig figs mean. If I have 4.9, maybe 356 times 10 to the 6th power, that's not sig figs. That's a big old number times 10 to the 6th. If I want to make it sig figs, what we do is 3 sig figs is what I'm going to always say. 3 significant figures, meaning I only want 3. So I look at the first 3. It doesn't matter that there's a decimal here. And I go to the 4th one. It's a 5. Generally, 5 will round up, right? So that is going to make this 4.9. The 5 is going to round the 3 to a 4. These I leave off. And then I say times 10 to the 6. This represents 3, 1, 2, 3 significant figures. Okay, let's try another one. Let's try 5, 8, 7, 6, 4, 3. Let's write that in 3 sig figs. Now, you're going to see it written SF. You're going to see me write that and abbreviate that. All right, so here we go. I'm going to give you a second to kind of think about it. I only want 3, so 1, 2, 3. I only want to focus on these 3 numbers here. 5, and then I'm going to go out to the 4th. The 6 is bigger than 5, so it's going to round that up. So 5, 8. The 7's going to turn to an 8. But what do I do here? can't just like, oh, 588. No, the number was 587,643. So I turn all these other ones into zeros. I'll put a little comma, and there's 3 sig figs. Okay. Let's go the other direction. 0.000079832. Again, we're going to do 3 sig figs. So now you're like, whoa, there's a lot of zeros. Well, I need to focus on the first number bigger than 0. Okay, so that's this one right here. From here, I'm going to focus on these 3 numbers for my sig figs. Now, I can't just forget about these numbers here. Those are placeholders. So I'm going to have to leave those. 1, 2, 3, 4. 1, 2, 3. I got to leave those. I'm going to have the 7, the 9, and the 8. I'm going to look at this one. The 3 is not going to affect the 8, right? Because the 3 is less than 5. So I'm going to put 7, 9, 8. These numbers do not change this value at all. Like these zeros here, they change the whole value. You want $588 or $588,000. Yeah, big difference. But here, this number here is 798. If I put zeros over, it doesn't change the number anymore. So this is my answer. 0.0000798. Now, just for kicks, let's turn that into a sig fig. 7.98 times 10. Now, I haven't counted anything. Is it going to be a negative or is it going to be a positive exponent? Well, since this is getting smaller, I'm going to have it be a negative. Let's see how many. 1, 2, 3, 4, one more, 5. So to the negative 5. This right here in IB is the cleaner answer. That's what I would call a cleaner, more significant looking answer. All right. Let's try another one. Let's try, let me change my pen. Let's try 0.012301. Again, we're going to write it in 3 significant figures. I'm going to give you a second to do it. I'm going to take a little drink of my water. All right, here we go. The numbers in the front don't matter. I'm going to focus on these 3 numbers right here. 1, 2. The 0 will not change the 3. I'm not going, you're like, oh, but wait, there's a 1 there. It doesn't matter. 3 sig figs means I'm focusing on these 3. These are not going to change the value. This one is not going to round it, so that is my answer. If I wanted to make it into scientific notation, 1.23 times 10, 1, 2. Negative 2. We will do so much of that that it won't even faze you. All right, so let me kind of sum this up. The number 0.00009893, the zeros here, they don't matter. You don't use those in your significant figures. These don't matter. However, if you had 3.0700, the zeros on the end here are very important. And now you're like, but wait, up here when you were showing us, the numbers over here didn't matter, but the numbers over here mattered. Here's what it is. If you're on the right side, this is the right side, these are very important. If you're on the left side, those are not important. That's kind of the way. Left doesn't matter, the right does. These were on the right. Oh, big difference. These were on the left, and you don't count them. They're still important when you're talking about value, but they're not important when you're talking about sig figs. You've got to get over to the numbers over here. Okay, and again, if those stump you a little bit, come see me. Let's do a tutorial over it. All right, the other thing I want to show you is something called the percent error. Okay, and we're going to write it as an E. All right, to me, this one's almost common sense. I will tell you, we are going to see percent error throughout this course a lot. So you want to make sure you have a firm grasp of it. We're going to write an E. Here's what the percent error is. You take the exact value, whatever it is you found, the exact value, subtract off the approximate value, whatever you approximately get it, and you're going to divide it by the exact value. Okay? Now I'm going to give you a scenario. We take the absolute value of it and we multiply it times 100. And that gives us our percent error, equals our percent error. I'm going to give you a situation that you're probably more familiar with. You take an exam. The exam has 24 questions, right? And you get 22 of those questions correct. What's your score on that exam? Like, what's your percent score? Hopefully you're thinking about it and you're saying, well, I got 22 out of 24, right? So you would take your calculator, you would do 22 divided by 24, and you would say 0.9166. So most of us would say, oh, we got about a 92% right on that test. Okay, same idea here. You took how many you got right, and you divided it by exactly how many were on the test. Exactly how many you got on the test, right? So when you're trying to remember which goes where, the exact amount, always go back and think about that test. How many did I get exactly right? And that, I don't know why, that just tends to resonate with me. And I'm like, oh yeah, the exact goes on the bottom. So here's the way this is going to work. You're going to solve a problem and you're going to find that maybe the answer was 7.65. That's what you got. When you did your estimation on whatever it is you're finding, you got 7.65. But then the problem says, but the exact answer, like if you were to use, I don't know, some big old machine, the exact answer was 9.3, we'll say 4. Now, these are just arbitrary numbers. Here's the exact value, and it's 7.65 was the answer you got. The question I'm going to ask is, what's the percentage of error? How much are you off? And you would say, okay, well, let me think about it. I need to take the exact, subtract off the approximate. So the exact, subtract off the approximate. But remember, it's a percent, so we're going to divide. What do you divide by? Always the exact. 9.34. Now we want to take the absolute value because sometimes the exact might actually be smaller. So we're going to take the absolute value and let's see what we get on this one. So we're going to do, I'm going to do alpha y equals because I like to do that. 9.34 minus 7.65 divided by the exact times 100. It's a big error. 18.094. Now, we're going to practice sig figs. 3 significant figures. 18 point, I'm going to focus on these 3. The 9 is going to round the 0 up to 1. And that would be a percent. Oh, IB is big on units. Like, holy cow, going from this to your units. Okay, that's how exact's going to work, how percent error is going to work. The last thing I want to show you is something called standard form. And this is just a notation. It's going to be A times 10 to the K. And then you're going to have this funny little bracket. And you're like, well, what is this K? Here's what it's going to say. K is an element of, and I know you probably have not seen that since geometry. If you even saw it then, maybe in chemistry. K is an element of the integers. And the integers is a capital Z with like a double line on it. That's how you write the integers. And this value A is 1 is less than or equal to A, which is less than 10. What in the world? What this means, write your answer in scientific notation. That's all that means. All that gibberish there, A times 10 to the K. Oh, A times 10 to the K. That looks like scientific notation. So you solve your answer and you get 931,210.39. That's your answer you got. But your problem says put your answer in standard form or in this form. And you're like, oh yeah, that just means scientific notation. Okay. 9.3, I need to focus on 3 sig figs. The 2 will not change the 1, so I'm going to leave it as 1. Times 10, okay, what did I do here? I take my decimal and I move it over 1, 2, 3, 4, 5 places. So that means this was my answer, 931,210.39. This is what I got when I solved the problem. But the answer says to put it in scientific notation or standard form. So I say, okay, I need 3 sig figs, 9.31. Move my decimal over, 1, 2, 3, 4, 5. There's my final answer. That's the one that IB's going to want. It's the nice, neat answer. Mathematicians like this. It's just an easier way to look at your answer instead of all that gibberish right there. All right, y'all, that concludes everything from day 1. I hope you followed along. If you struggled with any of that, just come see me. We'll go over some more. We are going to do this kind of stuff all year long. Like this percentage of error, it was all over the IB exam. We're just going to do it all year long. Thanks, guys.